Hi, everyone. My name is Jasmina Lazendic-Galloway, and I'm a research fellow at TU Innovation Space and Eindhoven University of Technology, and also adjunct senior research fellow at School of Physics and Astronomy at Monash University. And I'll be sharing with you today how you could use challenge-based learning to tackle societal issues through astronomy education. So my experience is teaching in higher education. I've taught for 10 or more years in first year and third year astronomy and astrobiology courses, but I also have very keen passion for public outreach. So I engage with a lot of schools, and my youngest audience were 3-year-olds and 4-year-olds. So very keen to involve learners at all levels in astronomy education. And now as an educational researcher, I'm also interested to understand which of these methodologies is most efficient and which kind of approaches are suitable for different learners. So one of the experiences where I applied challenge-based learning is in my MOOC that I created with my colleague from chemistry, that we ran between 2016 and 2018. And the MOOC basically represented challenges of living on Mars or surviving on Mars. And the course ran for 4 weeks, each week representing different challenge, how to create water, how to create oxygen, where to get energy from, how to produce food. What our learners had to do is, with every week as they learn new information, they have to adapt their plans and solutions to then include more complexity. And so it was very open-ended and also involved learners at all levels. So it was mainly sort of aimed at high school students, but we had learners at all levels. And obviously it was inspired by The Martian, the book, and by this idea that science is excitement about challenges to be solved. And what we found is that the learners very often reflected on availability of Earth resources. So as you probably all know, astronomy and space exploration can be a really powerful tool to engage public with issues that we have here on Earth. So I really became more interested in challenge-based learning from that point on, mainly because I saw from learners this real excitement about very open-ended challenges. So not something preset that we want answers to, as they used to in science sometimes, but something that kind of presents to them, here are these big challenges. How would you go about solving them? And where can we make contributions? In which direction we have to go and pursue these solutions? So challenge-based learning kind of started with Apple and its collaboration with high schools in US, high schools, but also primary schools and universities. And they developed their own framework, which basically have sort of 6 steps, where you have this big idea that you start from, and then you distill these essential questions that this idea represents. And then from essential questions, you choose your challenge. And then within the challenge, you go through guiding questions, guiding activities, and guiding resources. Then you come up with solutions, and you have the solutions lead to an action, and then this is assessed or evaluated, and then you share what you found. So it's a very flexible approach to learning. And what I like in particular about it is that basically involves students interacting not just between themselves and instructors, but also with external stakeholders. So you can have government agencies, you can have societal organizations, you can have industry, but you can have this expertise brought into classroom from various sources. So this is roughly the framework that Apple has defined with the teachers. And since then, there has been some modification, especially as this passed on at higher education. So there has been some modification of what these challenge-based learning key characteristics are. But it basically what remains is that the challenges are open-ended, which means there is no preset expectation of what the solution should be or in which direction it should go. But I won't go into more details about framework because you can find more information at these links. I just want to share some examples. So from the Apple's document, which is about classroom guide to challenge-based learning, you have some ideas like sustainability, climate change, public health, economy, conflict and human nature, cultural identity, health and wellness. And so, as I mentioned, this challenge-based learning have been around for a while now. And after this initial implementation, Apple did evaluation, and you can see that some of the primary schools participated, as well as high schools and some universities. And the finding was that CBL was very effective in building 21st century skills. 90% of teachers reported some of the key skill areas improvement significantly. So leadership, collaboration, adaptability, creativity, critical thinking, communication, innovation, initiative. And 80% of teachers reported the additional 6 key skills that are improved. Things like productivity, accountability, information literacy, social skills, self-direction, global awareness. Over 3/4 of students across every age felt that they learned more than they expected, and that they work harder on the CBL project than they would normally work at their schoolwork. A quote from elementary school student is that I felt everyone partaking in this study is making a difference. The way we make a difference is by giving solutions to problems and fixing them. Even a kid can make a difference somehow. And also what's important, of course, is that teachers felt that their students across all the levels mastered the expected material, and that overall engagement increased, and that CBL was a good use of class resources and time. And of course, for teachers, most importantly, they felt comfortable in using and implementing a CBL, and they understood what are the components of this approach to teaching. So how could we use this in astronomy? Well, we have compilation of big ideas in astronomy, and there's about 11 of these. And in the last one, the 11th one, is probably the most obvious where CBL can be employed. So the 11th one talks about preserving Earth as our only home in the universe. And so we have about 7 themes there: light pollution that affects humans, but also the animals, a lot of space debris in Earth's orbit, monitoring hazardous space objects like near-Earth asteroids, and the fact that humans have a significant impact on Earth's environment, the climate and the atmosphere heavily affected by human activity, the global perspective that's necessary to preserve our planet, and the fact that astronomy can provide a unique cosmological perspective that reinforces the unity of citizens of Earth. So from these topics in Big Ideas in Astronomy, students can start thinking about what could be essential questions, and then from those questions develop challenges. But what I also like about challenge-based learning is that rather than just consuming and reproducing the information, students are actually engaged in creating and producing this new knowledge through this process and the product of the challenge. And besides sort of looking into access to information, because they want to know more, and then they direct their learning to know more about certain things. And we had that in our MOOC, where what our learners really liked, for example, is the fact that we would present some basics, provide some basic reading material, articles, and access to some of the information, but then that would motivate them to go and look for more and search for more and connect the dots and sort of zoom in and focus on particular aspect of that problem that interests them the most. So this is what challenge-based learning is meant to do. It's meant to transform students into lifelong learners who seek information and knowledge from different resources. So these are some of the key characteristics that I find very useful and enable very, very flexible approach to learning. And what I'd like to do is have a community of practice which would be interested to apply this approach to learning using astronomy, where we can share resources and provide support from experts and wider community, and also share lessons learned and ideas for implementing this kind of learning in astronomy. So thank you very much for listening, and feel free to get in touch if you have any questions.